Assalamualaikum. Welcome to this research presentation. The research title is Transfer Learning on BC16 for the classification of potato leaves infected by blight diseases. Myself, Jasmine Akhtar, and the co-authors are Mohammad Harunur Rashid, Al-Akhir Noyon, and Professor Mohammad Ghulam Kibriya. The outline of the research are aim and objectives. The objectives and aim are given here. Plant diseases are one of the most important elements impacting food supply and minimizing production losses. Around the world, the crop disease created problems on food insecurity and domestically losses in crops productions around the world. Hence, computer vision empowered with artificial intelligence has tremendous promise for improving agriculture, namely agriculture intelligence, as it is a part of the industrial technological revolutions. As deep learning approaches have recently expanded their applicability in plant disease identification, providing a comprehensive tools with extremely accurate results so that the crop disease detection can be handy. The next outline is motivation. Here is the motivation why motivated for this research. Plant diseases are one of the great challenges that face the agriculture sector worldwide, where agriculture contributes to 6.4% of the entire world's economic productions. Blight is still a global danger to potato crops and so more crops around the world, costing an estimated $6.7 billion in output losses and management expenses each year. The fungus-like pathogen causes black lesions and other disease symptoms in vulnerable cultivars, quickly destroying the plant's leaves, stems, fruits, or tubers. This is the outline of related works of this research. In 2018, Barbados suggested an automatic plant disease detection, where the proposed system is the most popular classifier, namely deep learning convolutional neural networks, where the methods have overcome some of the critical challenges. Sen et al. Lays out the criteria for choosing a convolutional neural network methods and findings a prepared deep learning approach for the method based application due to obtain robustness and performance in detection. So the performance can be faster than previous one. This is a project-based survey of artificial intelligence and deep learning applications in robotic harvesters, where robotic can be capable of to disease detect in an efficient way. Darwish et al. In 2020 focuses on using two pre-trained convolutional neural networks to create an automatic classification model that distinguishes between infected and healthy maize leaves. Their models are all trained with an exponential rate decay schema, via result alternative approaches. Their experimental results are compared with the performance of other pre-trained CNN models, namely Inception B3 and Exception, whose parameters were selected using a non-evolutionary method. This is the dataset used for this research. The data are 42 blight diseases containing digital criteria. There are two sets of data, and one early blight and the other one late blight. Early blight symptoms are irregular spots, black or brown on the leaves. On the other hand, late blight symptoms is a large black spots where the black spots can be destroyed the leaves within a few days. And these symptoms also can be happened on the crop's stems, even if can be destroyed whole crops of potato. Proposed architecture. There for the research, survey leaf images around to 10,000 and to 500 for early blight and 1,500 for late blight are finally selected for this research. As all the images are collected from various devices like Android versions and iPhone and digital camera, all the images are in various size or resolutions. So image processing is needed here. And in the image process, online photo editor, filter, and PC editor are used here to maintain to ensure all the image in same resolutions and all the image are digital image. For the next step, need to categorize two sets or two classes, namely early blight class and late blight class, and store their two classes in the Google Drive to storage so that when work with collaboratory Google Collaboratory, the path can be identified from the Google Drive. After that, the Keras library and other methods are used with Python and model training, model testing, and validation of BGG16 model built here. BGG16 model has lots of feature and weights uh, for the small sets of data sets, and that is and the build model can be categorized two sets, either it early blight disease or it late blight disease. Proposed architecture: figure 1 of the BGG16 and figure 2 BGG16 with the research customized business system. Here from the figure 1, the late blight image of digital image is selected. Then two convolution layer followed by a pooling layer, and this criteria continues to two times. Then again three convolution layers followed by a pooling layer, and this criteria continues three times. Then output layer are continued. Output layer means dense layer. Uh, Before the dense layer, a flatten added, as flatten is for one dimensional, cause the dataset used here is digital or three channel, as they are RGB image. So flatten is needed for one dimensional. Uh, from the figure 2, can compare with the PCC system and the customized PCC system. From source image dataset to PCC system model, classified in 1000 classes of ImageNet dataset, where the research used this real image dataset and BGC system model, but as there is no needed to 1000 classes of image dataset classify used here to potato early blight and late blight. So uh, instead of using 1000 classes of ImageNet dataset layer, used here two units of softmax dense layer instead of second last dense layer, and that is the outputted as two classes of potato disease, either it or early disease or late blight. List of components used for hardware: digital camera, Android phone camera, iPhone camera, and Dell Inspiration used for Google Collaboratory. For software, Google Collaboratory used two Python implementation for the research work, and GPU, which is virtual, provided by Google Collaboratory and Google Colab, which is used for data storages between two classes in early Blight and other is late Blight. Language used here is Python 3.9.0 version. The research test output from the figure, the green line shows the loss and the red line shows the validation loss. And here the blue line shows the accuracy, while the orange line shows the validation accuracy. Here the epochs are used only 20, and in between after 70 epochs, see that orange line approximately similar to blue line. That means it is almost around 96.30% of accuracy, which is the best validation accuracy in this research. The specialty of the research, the model obtained from this BCC16 is can be deployed into various hardware architecture device like Android device, and the Android device to detect this disease in real time need to model deploy firstly into Android Studio, and the Android Studio uses library can be implemented into an Android phone to disease detection. BC16 model is user-friendly to implement this kind of work, as BC16 has lots of words and features to detect and learn. If any small data set are available, so for transfer learning is the best approach for these small data sets. This is utilized in this research. Usage process and guidelines are easy to implement as the guidelines are available in the web. Conclusion: transfer learning has the potential to help overcome digital image disease detection problem and adapt the model to new tasks. Even if if have any small data sets, then transfer learning is the best approach to obtain best validation accuracy. Build model has been tested that performed well for both web and mobile version. After the build model deployed into for Android or others. This approach can be increased demand for modern computer vision, deep learning, and artificial intelligence tool as for the remote disease detection or through internet disease detection. This is the research presentation. Thank you, everyone.